Hello there, and welcome to our webinar, Streamlining Engineering Change Orders Management in Complex Harness Designs. I'm Ilkan Osavim, Assistant Editor and your host from AMS, the go-to publication for all things automotive production. Whether you're an automotive engineer, a manager, or just passionate about the future of automotive production, we're thrilled you've joined us today on this crisp 11th of September, 2025. First off, a big thank you to our partner, Siemens, for sponsoring this live stream and for sharing one of their top experts with us, Saket Verma, a gentleman I'll be introducing you to shortly. Now, as we are all painfully aware, in today's unrelenting and quickly shifting automotive world, vehicle design is being propelled to new levels of complexity, and therefore managing these changes efficiently is a make or break, non-negotiable for automakers everywhere. Wire harnessing is more than just a tangle of wires, the finely wrought and intricate nervous system of the vehicle. A single wiring harness in a modern EV can involve thousands of connections spanning sensors, batteries, powertrain components, and more. And with regulations tightening, customer demands evolving, and supply chains still attempting their as yet to be determined recovery from global disruptions, engineering teams are juggling multiple revisions, modular components, and tight deadlines like never before. But here's the kicker. Traditional methods of handling engineering change orders, or ECOs, often leads to major headaches, manual tracking, overlooked impacts and overwritten updates, and costly rework, of course. In many ways, it's like trying to update a huge and intricate jigsaw puzzle while pieces are still being added or removed. Of course, delays can rack up millions in lost time and resources, and in an industry racing towards net zero emissions and smarter manufacturing, we just can't afford that. That's why today's topic is so timely. We'll dive into how advanced tools can automate this process, reducing risks, speeding up iterations, and even helping with cost analysis before changes even go live. At AMS, we've covered stories from OEMs like Tesla and Ford, where harness design challenges can potentially directly impact production ramps. In other words, it's something that really has to be looked at and something that has to be optimized across the board. For instance, recent reports highlight how EV harness complexities have contributed to assembly line bottlenecks, emphasizing the need for smarter ECO management to keep innovations on track. If you're dealing with these issues in your own automotive projects, this session will equip you with insights to streamline your workflows and boost efficiency. Now, to guide us through this, I'm excited to introduce our speaker. With over 20 years in product development, quality assurance, and engineering leadership, he's a true veteran in our field. Our guest serves as a senior project manager even to Siemens harness product line, driving strategic alignment and technical delivery for a world-class company. Ladies and gentlemen, please welcome Saket Verma, senior product manager at Siemens Digital Industry Software.
Hello everyone. I'm going to talk about streamlining ECO change management in complex harness designs with capital. A quick background about myself. I have 20 plus years of experience in product development, quality, and engineering leadership. Currently, I'm working as product manager for harness product line in Capital. I also have experience of working with one of the wiring harness manufacturing company, Motherson Sumi Systems Limited in India. Let's look at one of the challenge that harness industry is facing. In the automotive and aerospace sectors, handling engineering change orders in modular wiring harness design is a major challenge. Teams often face multiple design revisions at once, with highly modular architecture and reused subassemblies. This leads to manual tracking of deltas, risk of regressions, and difficulties in visualizing and applying changes with confidence. Traditional change management methods simply don't scale here. Without automation, like baselining, impact analysis, and safe merging, engineering teams run into delays, rework, and quality issues, which directly impact program timelines and customer commitments. When we talk about change management in wiring harness design, it's important to know that this is not just a capital topic. Yes, capital provides a rich set of capabilities to support change management, especially in design and manufacturing engineering. But in reality, change management is much broader. In large companies, CADs, CDE tools are surrounded by higher level PLM and PDM systems. Teamcenter is a good example. These systems connect a much wider set of user, program management, sales, procurement, logistics, costing departments, and more. They all rely on common change management process, which means capital has to both consume and provide data into the ecosystem. Here is a generic flow of a change through different departments. We are in product engineering, but we are not alone. There is manufacturing engineering, but there are other people like program management, which are not capital users. As all, they may be costing. There is purchase indefinitely, again, no capital. These people have to work together in a workflow. So for example, they receive the request from program management. They ask product management to find out what this change is, how this change will impact us. Product management then informs the manufacturing engineering for the same reason. They need data to do some quotations. They need to create the data. They process all the data and find out which child designs are impacted. Same thing happens on the manufacturing path. They try to find what impacts they have. They all report back to the costing department. They code the change. Product management has to approve. And only if this is approved, we then implement that change and release a new version of the harness. This is an overall flow. Maybe that not all harness makers are working exactly like this, but more or less they all find in this kind of flow. We consider the timeline from left to right here. We are not sure if the changes will be approved. First of all, on the left, we only have to create the data for quotation and see what the impact is. And this could be many things. It's not only to do with the material. Do we have all the tools? Do we have everything for the foam board? So there is a lot of information which needs to be collected together. And we can only do this if we have the proper data. So we have to implement the change into, let's say, a copy of our harness design data. And we have to run a costing process. And there is the time in the process where we know the change was approved and now we have to release a new version. In the past, normally what happened is we created lots of documents and drawings on the left hand side. And then when the change was approved, we had to do the exact changes again, exactly the same work, because now it's approved. This is what we have improved with our capture and apply ECO. You can now reuse the work which you did on the left side when it comes to the right side. Now you can capture and apply your changes. Let's look at the solution that we have in Capital. What I'm going to present today is part of the change management. Change management, as we all know, is very broad. What we'll be focusing is the capture and apply of ECO. Firstly, why capturing and applying ECO changes is essential in harness design. On the capture side, the idea is to record design changes with intention of linking them to an ECO for later use. These changes might be needed across multiple designs, or they may not yet be approved but could become relevant in a future revision. Often there are several change requests, but the sequence of implementation isn't always clear. Similarly, customers may want costing on a range of requests, but will only decide to proceed with some of them. On the apply side, once the ECO is approved, those stored changes can then be implemented in one or more harness designs. At this stage, conflicts may need to be resolved, and some diagram cleanup may be required to finalize the design. So in short, the process allows teams to capture changes early, keep them organized, and then apply them efficiently when the timing and approvals are right. Here we will cover some of the basics of capturing and applying ECOs in Capital. Engineering change orders are used throughout Capital design tools to document and manage design change requests. The capture and apply ECO functionality is specifically available in Capital Harness XC and Capital Modeler XC. What this enables is the ability to capture design changes, store them in an ECO, and then automatically apply them to a target design when needed. It is important to note that this functionality worked on design data changes, and recently we have extended the support for diagram level changes too. Also, when applying changes, the process cannot continue where there are conflicts. Those must be resolved first. We will look at conflict handling and resolution in more detail a bit later in the session. How design changes are captured in Capital using ECOs? The process is straightforward. First, we take a snapshot of the design data before any changes are made. This is our baseline. Next, we take another snapshot after the changes are applied. Both the before and after states are then stored inside the ECO. This approach ensures we always have a clear record of what has changed, making it easier to track modifications, manage approvals, and maintain design integrity across revisions. How we apply design changes using ECOs? First, we take a snapshot of the target design data. Then we use the baseline and after data stored in the ECO as our reference points. The system compares the target design with these snapshots to identify what needs to be updated. Finally, the applicable changes are applied directly to the target design. This approach ensures that only the intended modifications are carried over, while maintaining traceability and minimizing the risk of unintended changes. Let's look how the change application process works through a three-way comparison with target, baseline, and after data. The ECO contains both the baseline and after snapshots, while the target design represents the live data we want to update. The system compares all objects and attributes using unique IDs and name matching, and then checks bundles using topology matching. Based on this comparison, it determines which changes can be safely applied to the target. A key rule here is that changes can only be applied if the starting condition of the target design matches the baseline. For example, you can't apply a change that assumes a wire was blue if in reality it's already green. This ensures consistency and prevents accidental overrides. So we know what the change content is from baseline and after. We can extract automatically the change content, and then we need to verify the target design to decide if we can do the change. We have till now looked into the basics of the ECO capture and apply. Now let's go through the complete capture and apply ECO flow. The first stage is to create an engineering change order or ECO for the change. We will document the ECO. We create the ECO and give it a meaningful headline and description. This ECO will track the status of the change all the way through capital. We can add screenshots and other attachments that may be useful to the engineering who will make the change. At the moment, the ECO is in the not started state because we haven't started to capture any changes yet. Now we start to capture the change. We move the ECO into the in progress state. At this point, the XML of the original design, before any changes are made, is stored in the ECO. We can now go ahead and make our changes. The change in this example is a clip, and we move this clip to a different position. The input here is a copy or revision of the design along with the details of the requested change, with an output as an ECO that contains the captured data changes, which can then be tracked through its life cycle. And this is the point in time where our after snapshot is created for you. All of this happens automatically. The user does not have to do things. The only thing he has to do is the logical transition of the ECO status from not started to in progress to completed. And then this can even happen over multiple days. So it's not important that this happens on the same day and at the same time. This can span over multiple days. So then by using this, we can create and control multiple ECOs, and then when it comes to apply, then we select the ECOs which should be applied to the target design. We can use these ECOs for costing and prepare the quote. We begin with a harness design and capture the requested modifications into an ECO. Once saved, these changes can be reviewed and rolled forward into the updated design. At this stage, multiple ECOs may exist, each representing different sets of changes. The key here is that the system can calculate both the labor and material cost associated with each change. This gives engineering and program managers visibility into the true impact of a design change, not just technically, but financially as well. So the input is a change design and with an output as a clear view of costed ECOs, which supports better decision making. So we can select ECOs which should be applied to. Maybe the two highlighted are not important or are not yet approved. Remember the three-way compare we discussed before? The change was we moved the clip from here to here, and there is a rule that the context of the change must be the same start condition, and this is the sets of objects which are impacted. There is a clip above. For this ECO, it does not matter, even if the clip was also changed to somewhere else before. This is not in the context of the ECO3. This is the power of capital. You can apply the changes in any sequence of their approval. Let's have a quick look at the demo in the software. Here I start with a new revision of a released harness. I have been assigned several ECOs that need to be quoted, and I'm going to use the power of capital to capture the deltas for each ECO as I work. Starting a change triggers a baseline snapshot of this design to be created and stored within the ECO. At some point, one or more of these changes might get approved, but by then the harness may have been through several more revisions. It is my job to apply just the approved changes, without impacting anything else I may have changed in between the initial capture and today. The first thing I'm going to do is take an earlier to remind me what is involved. Now, in the past, I would either have to manually make the updates to my harness or I would have to deal with the merge conflicts when comparing design revisions or make changes in the sequence they were captured. But because Capital stores both the deltas of the change and a baseline snapshot of the original design, the automation within the tool enables me to apply the change safely, no merge conflicts, and it preserves any other updates I may have made to this revision. This technology means I'm free to apply changes in any order they come in. I'm now applying another ECO in the same, not in the same sequence as I captured them, and going to apply it on the harness. I'm going to process it and apply the changes. Now I'm applying the ECO here to the composite harness, one that has already been through the modular breakdown process and has multiple child designs associated. Using Capital's change impact capability, I'm easily able to see both graphically and in the table below which parts of which child designs have been impacted by this ECO. I can then choose to revise those affected designs directly and continue with my work. I can directly go and revise the designs, the impacted designs. I don't have to go outside and revise all the child designs. So that's the power of Capital. I can get the information about the impacted child designs, directly revise them, and move on with my work. Thanks, everyone.
Excellent. Thanks, Saket. I mean, clearly the urgency to address wiring harness ECO challenges is pressing. Whether it's streamlining rapid design evolutions or mitigating production bottlenecks, the insights shared today offer our perceptive audience members a roadmap for engineers and manufacturers to enhance efficiency and innovation across the automotive production and even aerospace sectors. Now, let's dive into some questions. Saket, I'd like to begin by asking you a question on complexity and scalability. Managing multiple revisions and modular harness architectures is a persistent issue. How does Capital ensure scalability for OEMs and suppliers who may be dealing with hundreds of concurrent ECOs across global programs?
Right. You're able to hear me, right?
Yeah, you are loud and clear.
Okay. Actually, Capital is built. It's basically an enterprise solution, right? And it is built on a scalable platform that can handle large volumes of data and users across global programs. To support hundreds of concurrent ECOs, it also offers automated workflows that streamline the change management from approval to the implementation, right? Reducing manual effort and ensuring consistent and efficient processing across the teams. So I think we understand as a Capital, as a Siemens, as a company, we understand the complete flow of ECO, and we ensure with the framework and the platform that we have that we are able to support these hundreds of concurrent ECOs across global programs.
Excellent. And on automation and confidence, I mean, you've touched on the capture and apply process for ECOs. Where does intelligent automation make the biggest impact? I mean, would you say it's in costing or conflict resolution or implementation? And how does Siemens ensure accuracy without losing engineering oversight?
Okay. Well, all three are targeted as an impact. But if we have to compare among the three, definitely implementation is where the customers will experience the most significant productivity gains. Since automation of capture and apply can safely apply the changes, and leveraging the capture and apply capability, the changes can be propagated directly, right? Eliminating the need to re-implement then them manually. You remember that the thing that I explained in the flow from left to right, right? Left
Yep.
is the flow where we are actually doing without knowing whether the ECOs will be implemented or not. But then now with the solution that we have with Capital, you don't have to redo it, right? You just use what you did during the quotation period and then just apply the changes once it is approved. So I think implementation plays a big role over there. But having said that, I'll say that if you remember, I explained the three-way compare concept. I think that's a real differentiator in itself, right? Because it reduces the errors also, right? You and improves the confidence in change application when applying the changes in any sequence based on the ECU approvals. So definitely implementation plays a big role, and it is something that is I will say the main thing, but where you see the significant productivity gains. But the three-way compare is a real differentiator for us. Yeah.
Okay, and one of the questions we have is on the team center integration. How critical is it to link harness ECO management with broader PLM and enterprise workflows? And what benefits does this bring in terms of time to market and traceability, would you say?
Well, connecting harness ECOs with Teamcenter, or in other words, with any other PLM tool, is very important because changes affect the whole company, not just the engineering, right? When ECOs are linked into the PLM and enterprise workflows, customers will see benefits where changes flow automatically to manufacturing and suppliers, resulting in faster delivery, right? With every change being tracked from from the request to the release. So this makes ECO management part of the full product process, helping reduce mistakes and speed up to time to the market. So yeah, definitely, yeah.
Yeah. And as you've already pointed out, I mean, ECOs often ripple through multiple diagrams and revisions. So how does Capital's impact analysis give engineers confidence that they've identified all affected systems? And what would you say differentiates this approach from traditional manual methods?
So, if you look into the traditional way, right, there was no way to identify which child designs are impacted with the changes in the parent design. User has to go and revise all the child designs, run the harness processing to propagate the changes to all the impacted child designs. This required unwanted revisioning of the designs that are not impacted, and running of the processing, which definitely takes some time if you are trying to run it on all the designs, even though they are not impacted, is a big effort, right? So with the capability of change impact, user can now avoid revisions of not impacted child designs and running processing on all the child designs, right? Uh, Capital Capital automatically identifies the dependencies, and how we do that is by analyzing the tagging. When I say tagging, it's basically the option expressions and the functional and the production module codes that we assign on the objects in the design, and the design object relationships, right? This systematically examination ensures that all design objects and their relationships are analyzed, leaving like we don't leave anything which is not covered in this, right? With the approach that we have. So the system categorizes impacts into added, modified, and even the deleted objects. And this detailed classification helps engineers understand that not just what is affected, but how it is affected. As I mentioned, all those changes can be seen both graphically and in the table that we saw in the demo, right? So yeah, that's
Okay, interesting. And with this is one of the questions that's quite pressing, as just the development of technology, the rate of change, with the growing complexity of electric vehicles and software-defined vehicle architectures. How do you see harness ECO management evolving in the next 5 years? And where is Siemens focusing its development to stay ahead of those challenges?
right. Well, definitely, this is something which is very important going forward, right? And as EVs and software-defined vehicles grow more complex, harness ECUs management is evolving quickly, and Siemens Capital is actively developing solutions to stay ahead. Uh, as you see, over the past few years, Siemens has focused on automating the ECU processes, improving the integration across systems, and enabling real-time collaboration for global teams. With the increasing number of design variants, obviously software-driven features and stricter negotiation regulations, uh, fast and traceable change management is more important than ever. So we are committed at Siemens to make sure that we are coming up uh, with a solution for each of the challenges that the industry is looking at. So yes, there is a long way ahead, but we are working with our customers. We are taking a lot of inputs from them, and we are continuously working towards that.
Perfect. Thank you, Saket, for those interesting insights. To our audience members, if you're interested in further understanding the dynamic between humans and machines in automotive production, looking at trends and opportunities in manufacturing user technologies, including AR and VR, cobots, IoT, exoskeletons, computer vision, and AGVs, then scan the QR code on your screen to make sure that you join us in less than 2 weeks' time on the 24th of September for our live stream, Shop Floor Tools, Human-Centric Digitalization in Production, where we'll be joined by execs from Audi, Gestamp, and ISA to excavate this layered challenge. And then to our major event. For those of you in North America, or those of you brave enough to venture out to North America to join, no less car makers such as Stellantis, Nissan, Ford, GM, and top-tier suppliers such as Bosch Mobility and Borg Warner, and many, many more, then again, scan the QR code on your screens or visit the AMS website to join North America's premier automotive manufacturing event, which will be at the Henry Hotel in Dearborn, Michigan on the 22nd and 23rd of October. We'll see you there. So thank you, Saket, for an insightful and valuable presentation. Thank you to our audience for listening so keenly. And thank you to Siemens for being the sponsors of this webinar. I've been Ilkan Osavim, Assistant Editor for AMS, and continue to be so. Thank you, and continue to follow us at automotivemanufacturingsolutions.com. Bye for now.